Hi, and welcome to Argonne National Laboratory. I'm Pat Hogan, Project Manager with Argonne's Facilities Management and Services Division. I was the construction manager for the Energy Sciences Building. I'm here today with two of Argonne's leading scientists.
Hi, my name is Seungbum Hong. I'm a nanoscientist in Material Science Division, and I'm working on visualization of functional materials using atomic force microscopy.
And I'm Alex Martinson, a chemist at the ESB.
Argonne is one of 10 national labs under the Department of Energy's Office of Science that integrates world-class science, engineering, and user facilities to deliver innovative research and technologies.
Here we are at Argonne's Energy Science Building, known as the ESB. This 160,000 square foot facility features 50,000 square feet of lab space to accommodate over 150 researchers. It earned the U.S. Green Building Council's Gold rating under their Leadership in Energy and Environmental Design program. ESB contains research infrastructure to conduct breakthrough developments for highly reliable, safe, and long-lived battery systems, cost-effective and environmentally friendly feedstocks and fuels, and groundbreaking systems for solar energy. There are 5 basic lab types, which include synthesis, instrumentation, characterization, wet chemistry and laser labs, as well as specialty shielded labs.
We designed the labs in ESB to accommodate the rapid changes in equipment, instrumentation, and technology that go hand in hand with scientific advancements. While the labs vary in size throughout the building, all labs are designed around a single module of 11 feet by 20 feet. The modular design of building systems, including mechanical, electrical, plumbing, and structural, allows for more efficient lab modifications than in traditional lab facilities. Electricity, chilled water, nitrogen, and compressed air are distributed through overhead service carriers, which allows scientists complete flexibility to rearrange equipment layout on the floor as they need. Mobile casework allows for easy reconfiguration of labs, which reduces renovation materials and waste. The building layout incorporates a service core that segregates loud or hazardous scientific equipment from other research spaces. This service area keeps hazardous equipment out of sight and helps maintain excellent environmental air quality for all other areas of the building.
The facility was designed to accommodate atomic-scale scientific research with laboratory isolation from acoustic, vibration, and electromagnetic interference. For example, for our research, where we visualize the behavior of nanoscale building blocks, we need to have minimum floor vibration in order to achieve high-quality atomic force microscopy images.
This facility, with over 100 fume hoods and 63 labs, requires a lot of energy. The building was designed to reduce energy consumption in many ways. For exceptional indoor environmental air quality, daylight illuminates all 3 floors of the building with a central atrium and floor-to-ceiling glass on the north facade. The south side gets more sunlight, so the windows are irregularly spaced to regulate temperature. In the lab spaces themselves, windows provide natural daylight and views to the outdoors. Lighting systems are controlled with occupancy sensors, photosensors, zoned light switches, and timers, which keep light at the recommended levels when in use or completely turned off when not in use. The laboratory supply and exhaust air use control valves that maintain the space temperature, pressure, minimum air exchange rate, and equipment exhaust needs. Air supply and exhaust vary constantly in labs to respond to the changes in room use. The high-efficiency fume hoods have sensors that calculate the required airflow rate based on the sash position. As the sash opens, airflow increases to maintain velocity at the opening. When the sash is closed, airflow decreases, minimizing the exhausted air and thus saving on the amount of conditioned air needed in the building.
As a researcher in the ESB, I appreciate the informal collaboration spaces in the lobby of each floor. For more formal discussions, we have multiple meeting rooms that can accommodate both small and large groups, as well as external collaborators who participate through video conferencing. Open offices shared between postdoctoral researchers provide another common space for free-flowing dialogue and mentorship. 2 outdoor seating areas offer a connection to the environment, and we often use them for lunch meetings.
A sky gate at the west end of the building anchors the pedestrian path linking existing north and south campuses and also provides a sheltered area with benches. Around the perimeter, the landscape is being restored to natural prairie by planting native species. The neighboring Materials Science Building is joined by an enclosed walkway, which allows collaboration and sample sharing with nearby Argonne scientists. The ESB is part of Argonne's campus vision to develop an energy quad. ESB, buildings 222 and 223, together with the future Materials Development Laboratory, currently in design, will be interconnected to support scientific collaboration and energy research. ESB is further linked to the nearby Theoretical and Computational Sciences Building, Argonne's supercomputing facility, via the campus pathway. 2 electric vehicle charging stations in the main parking lot enable Argonne employees to charge their personal electric vehicles on site in support of green commuting.
ESB demonstrates state-of-the-art energy efficiency and environmental stewardship in building design and construction.
The ESB project won 4 awards, 2 of which were the Department of Energy's 2014 Secretary's Achievement Award and the Chicago Building Congress Best Suburban Project of 2014 award.
The research conducted in the ESB is redefining state-of-the-art energy science that will advance America's scientific excellence and helps pave the way to a nation with a supply of safe, sustainable energy, a healthy environment, and a competitive economy.